Okay, two short ones to start off this tutorial sheet. So, first off, what we're going to do here is solve 2 to the power of 2x minus 10 to the times 2 to the x plus 16 equal to 0. Okay, so just what we're going to do here is let y equal to 2x. Okay, and just actually as a consequence of that, x is equal to log of y to the base 2. Just remember that for later on. Okay, so if y is equal to 2 to the x, y squared is 2 to the power of 2x. Okay, so just remember that little rule there about powers. When you square something to a power, you get up 2 to the power. Okay, so essentially 2 to the power of x all to be squared is 2 to 2x. Okay, that's I'm making a meal of it there, but actually just remember that rule. So what we're going to do here is just express this equation, the one we have above here, just re-express it as follows. Y squared minus 10y plus 16 equal to 0. Okay, so when we factorize that, we get y minus 2 times y minus 8. That's equal to 0, so therefore y is equal to 2, or y is equal to 8. Okay, so we're nearly there, and essentially the answers we're looking for is in terms of x. Okay, so we get log to the base 2 of both of those. So log to the base 2 of 2 is simply equal to 1, and log of 8 to the base 2 is 3. So the answer is, let's just write that a little bit clearer. The answer is 1 and 3. X is equal to 1 or x is equal to 3. Okay, good. So the next question is as follows. Find two numbers, the sum of which is 25, and the sum of whose logarithms to the base 10 is 2. Okay, so we have two numbers, we're going to call them x and y, and the sum of those numbers is equal to 25. And log of x to the base 10 plus log of y to the base 10 is equal to 2. Okay, so that's just actually what we have above here written mathematically. So just a little bit easier to follow. So just actually going to start off here with the 2. Okay, so 2 we can actually express that as log of 100 to the base 10. Okay, so essentially we can write all of this equation here in terms of terms that are written in terms of log to the base 10. So we have log to the base 10 of x plus log to the base 10 of y. Oh, sorry, and that is equal to that is equal to log of x plus y. Sorry, log of x times y to the base 10. Okay, so what I'm saying is that this component, this here is equal to this here. Okay, so log to the base 10 of x times y is equal to log to the base 10 of 100. So we have x times y is equal to 100. So just actually one or the other, y is equal to x is 100 over x. Essentially what I'm going to do now is try and solve this. So I'm going to use this expression here. I'm going to sort of simplify it in a way that I can substitute it back into the other equation. So y equals 100 over x. Okay. So above we had x plus y is equal to 25. So substituting 100 over x in place of y, we have x plus 100 over x is equal to 25. Multiply the whole thing, each expression here, by x. So we have x squared plus 100. 100 over x times x is simply 100 equals 25x. Re-express that, we have what we have here is a little quadratic expression. X squared minus 25x plus 100 is equal to 0. Essentially, from the line above, we subtract 25x from both sides. Okay, so we're nearly there. So we factorize that. Okay, actually, let's just we're going to factorize this expression here. X squared minus 25x plus 100 equal to 0. When we factorize it, let's straighten that up. X minus 1 times x minus 20 is equal to 0. So x is either equal to 5 or 20. Okay, and by the consequence of y being 100 over x, y would be 20 or 5. So essentially, they're interchangeable basically. So the answer is x is equal to 5 or x is equal to 20, or vice versa. It doesn't really matter which. Okay, so essentially the two numbers are as follows. X equals 5, or one of them is 5, one of them is 20. That's all you need to know, or that's all you need to answer. Okay, so we'll leave it there.